Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the Number Theory and Abstract Algebra chapter, and this question, I would say, is about medium difficulty. We're told that H is the set of all group homomorphisms phi from Z3 to Z6, and we're asked how many functions does H have. So what we have to remember here is a few things. One is that Z3 is cyclic. So actually we can characterize any homomorphism by what it does to the identity element, to 1, because Z3 is cyclic and it's and generated by 1. So if we know what the homomorphism does to 1, then we know everything about this homomorphism. So let's think of all the functions, all the potential homomorphisms, we have to check them, that can be from Z3 to Z6. So I'll just remind you that Z3 contains the elements 0, 1, and 2, and Z6 contains the elements 0, 1, 2, 3, 4, and 5. Okay, and we're doing modular arithmetic, modular addition here. And so let's look at the first option, which is that, let's call it phi 0. And let's say that phi 0 takes 1. Sorry. It takes 1, and it maps it to the 0 element. Okay, there's 6 options. It could go to 0, 1, 2, 3, or 4, or 5. Well, that's just the trivial homomorphism. It'll map all the elements to the 0 element. So yeah, that works. Let's look at phi 1, which maps 1 to 1. Well, let's think about that. What's it going to do? It's going to map, what is phi of 2 going to be? Well, that's supposed to be phi of 1 plus phi of 1, which is going to be 2. Okay, so far so good. And, well, what's phi of 4 going to be? Not 4, but, hold on. Phi of 2 plus 2, well, 2 plus 2 in Z3, that's 4 mod 3, so that's just 1. Okay, this is supposed to be 1. Well, phi of 1, this is supposed to be 1. Let's write that here. 1 is equal to phi of 2 plus 2. But if phi were a homomorphism, so here's the question mark, this would be equal to phi of 2 plus phi of 2. Well, we know that phi of 2 is 2 and phi of 2 is 2, so 2 plus 2 is 4 in Z6. So these are not equal. 1 is not equal to 4, so this is not a homomorphism. Another way to notice that this is not a homomorphism is that the image of all of Z3 under this function is just going to be the set 0, 1, or just, sorry, it's going to be the set 1, 2, 3, which is not a subgroup of Z6 because it doesn't contain the identity 0. So this cannot be homomorphism. Alright, let's look at phi 2. Okay, which maps 1 to 2. Is this a homomorphism? Well, let's see. Phi of 2 is going to be phi of 1 plus phi of 1, which is going to be 2 plus 2, which is 4. Now, let's see. 4 phi of 2 plus 2, let's do the same thing that we did before. 2 plus 2, we know in Z3 that's 1. So phi of 1 has to be 2. But if this were a homomorphism, we're going to put a question mark here, that should be equal to phi of 2 plus phi of 2. Well, phi of 2 is 4, and 4 plus 4 is 8 mod 6, which is 2. So that seems to work. So yeah, phi 2 is a homomorphism. Okay, so that works. Let's look at phi 3. Well, phi 3 of 1, that's going to be 3. So this is phi 1, phi 2. This is going to be phi 3 of 2. That's going to be 3 plus 3, which in Z6, remember, that's 0. Now let's think about phi of 2 plus 2. Well, 2 plus 2, we know that in Z3 that's just 1, because 4 mod 3 is 1. So that's supposed to equal 3 in Z6. But it's also supposed to equal, and here's the question mark, phi of 2 plus phi of 2. Well, phi of 2 is 0, so we get 0 plus 0, which is 0. So this does not work, because 0 is not equal to 3. Alright, so far we have 2 homomorphisms. Let's check phi 4. Phi 4 of 1 is defined by phi of 1 equals 4. So phi 4 of 2 is going to be 4 plus 4, which we know in mod 6, that's going to be 2. Now the question is, what is phi of 2 plus 2? Well, we know that 2 plus 2 in Z3 is just 1, so that's supposed to be 4 in Z6. Well, let's find out if it really is. So here's the question mark. Phi of 2 plus phi of 2 is equal to 2 plus 2, which is equal to 4. Yeah, that works. So that one is a homomorphism. And the last one we have to check is phi 5, which is defined by phi of 1 equals 5. So phi of 5 of 2 is going to equal 5 plus 5, which is 10. And if we take mod 6, that's 4. Now let's find out what is phi of 2 plus 2. 2 plus 2 in Z3 is 1. So phi of 1 is supposed to be 5. Now the question is that the same thing as phi of 2 plus phi of 2? Well, phi of 2 is 4, so 4 plus 4 is 8, which is 2 in mod 6. So this is not a homomorphism because 2 is not equal to 5 in Z6. So we end up with 1, 2, 3 homomorphisms. So the answer is C, 3.